Welcome to this screencast. I am going to demonstrate you the process of finding a complex system bug in Windows XP that is triggered by Adobe Flash player. The bug is that the monitor does not turn off for power saving. The tools and references I used include Process Monitor, IDA Pro, SoftICE, and some leaked Windows 2000 source code. The process will be described in discrete steps. So let's start. The first thing I had to do was to discover where the monitor power off timeout was stored, who stored it, and who accessed it. I opened the power options properties and the process monitor, made a change in the applet, clicked apply, and observed the output of process monitor. Now I filter only reset values and go and see the stack where I can see the NT power information system call. This call sets a value in the registry, the power policy, which I'm going to look right now. Okay, it is here, AC policy, which is unfortunately binary, so I can't extract any more information. So I'm going to find more about the NT power information function now. I'm going to look in the Windows 2000 source code for references. I have found some references in the control panel itself, the powerprof.c file, and the most interesting function code looks like this. It's a pointer, function pointer. First parameter is an enumeration, and interesting here is the structs, power policy. So I'd like to know more about the struct. Fortunately, it's defined in winnt.h, which standard is decay. Here it is, and we can see further down that it has a D word, video timeout, which is probably what I am looking for. The offset is C0 hexadecimal. Okay, next step, open NTOS kernel into IDA Pro and try to understand what NT power information does. Okay, looking through the assembly code, we can see some logs acquired. Okay, the accumulator here has the enumeration, which for our case is 0. Okay, moving further down, some checks for the buffers. And we have here a switch statement. Oh, you can see that, the table. And we have our case here, case 0, which pushes some values and calls pop apply policy. Let's see what that does. Okay, I'm going into that. Moving further down. Okay, here we can see some things like a registry key name. Okay, so it does a verify here, verifies the policy, and checks if the new policy is the same as the previous one. Okay, keeps checking the stuff. Okay, now here we can see does a memory copy from the policy given after the verification to where? To EBX. Let's see what's in MBX. Let's go further up. Okay, here it is. It's a global variable, pop AC policy. Okay, probably in the kernel memory. So I have to see what's in there. Okay, going to the virtual machine and using SoftICE. Okay, first start SoftICE, and I will set a memory breakpoint at that structure POP-AC policy plus C0, which is the video timeout, as we have seen previously. Okay, I've done that. Now I'm going to trigger a change. Okay, let's open the Power Options Control Panel applet. Okay. Oh, we see some triggering here, but it's probably not interesting. Let's step over. Okay. Okay, here it is. We see here the memory copy. We don't care about them, and we see here a function, the pop dispatch policy callout. Okay, we have to see what that thing does. Back to IDA Pro. Okay, let's look for that. We're looking for pop dispatch policy callout. Okay. Here it is. Okay, what it does here? It pushes video timeout, pushes a value 2 and calls pop event callout dispatch. Okay, let's see. Calls another function with the video timeout in the stack. Okay, that's the function. Yep, that's the one. Okay, let's remember the first parameter is 2 and the second is video timeout. Here it is. What it does here is another call, pop event callout, which is a function pointer actually. So I don't know where this function goes, where this call goes. I have to see the kernel memory. So I'm going to go to SoftICE again. And inspect this global variable. Again, let's do an inspection. Let's pop event callout. Yes. Okay, here it is. The address. Let's unassemble here. Oh no, probably paged out. No, I can't page in right now. So let's trigger a breakpoint somewhere else, so we can see where this thing goes. Let's just trigger some. Okay, here it is. Okay, let's unassemble. Okay, it is in Win32K user power event callout. Okay, it probably resides in another module. So now I'm going to see what this thing does, and it's in the source code. It's a file power.c. Okay, let me go and see what it does. Okay, here it is. User power event call out. It does a queue power request. Okay, it inserts probably something in a queue. Okay, we can see that it does actually insert something, and after that it calls XXX user power callout work here. Okay, where is that?